Welcome back, EDP students. In this video, we're going to look at binary, decimal, and hexadecimal once again, but this time in terms of code. So firstly, we're going to create a variable named x, and it's of type byte, so it's an 8-bit variable. And we're going to store the decimal number 21 in x. Then, I've got another variable called y, and this time I'm going to store 0b10101. What the 0b means is that the number that follows it is in binary representation. So we're storing 10101 and we're just represented it in binary. So if you want to represent your number in binary, you write 0b at the start. Lastly, we've got a variable called z, and this variable is storing 0x15. The 0x says that we are storing a hexadecimal number, so after the 0x is our hexadecimal number. Now, the important thing to recognize about this, that in memory, everything is stored in binary. No matter if we're using decimal representation in our code, it still gets stored in memory as binary. So we have x, y, and z, and how they are stored in memory looks exactly the same. And the reason for this is because 10101 in binary is 21 in decimal, and it's also 15 in hexadecimal. So all of these, even though they're in different representations, they still represent the same number. And we can print them out or read them using different representations, but they all still represent the same number. And if we do the conversions, we can see that. So the next thing we're going to look at with binary is often we want to specify specific bits. And to do this, we number the bits from 0 to 7, starting from the right-hand side. So we can see here the bit 0 of z is a 1. Bit 1 of z is a 0. Bit 2 of z is a 1, and so on. Make sure you're careful with this. Don't start at 1, and make sure you start from the right-hand side or the least significant bit. Alright, so now that we know that our variables are all stored in binary, often we want to look at a particular bit and see if it's a 1 or a 0. So to do this, we can use the function bitRead. So to use this function, we have to pass two arguments. And in the example here, we've got x and n, such that x is the input variable, and n is the bit we want to check if it's a 1 or a 0. So let's continue with an example. So we've got a variable called a, and we're going to store 10101010 in it, and we've represented this number in binary. So now we're going to create another variable called b, and what we're going to store in it is whatever this function returns. So we're going to use bitRead on a as our input, and we're going to check bit 3, remembering that our bits start from 0 and they start counting from right to left. So if we have a look at bit 3, we get a 1. So that means that b stores a 1. We'll now have a look at another example. So we've got a new variable called c, and what it holds is whatever value is at bit 4 of a. So if we have a look at bit 4, it's a 0, so byte c holds 0. Alright, so now we can see how to read. So now we want to see how to write a bit to a particular position in our numbers. So to do that, we use the function bit_right. And as an example here, we've got the arguments x, n, and b, such that x is the input variable, the one we want to change, n is the bit we want to change, and b is either a 0 or a 1 if we want to change that bit to a 0, or if we want to change that bit to a 1. So let's have a look at an example. So I've got a variable called d. Now, for this variable, I've written 0 in decimal. And so what that means is that in binary, it's all zeros. Okay? We then write bit_right. Now you'll notice that I'm not storing anything here because I'm changing d. So bit_right, my first argument is d, because that's the one I want to change. I want to change bit3, and I want to change it to a 1. So after running this function, I get 0, 0, 0, 0, 1, 0, 0, 0. And if I read that in decimal, that is decimal 8. Alright, that's it. Thank you very much.